We will now use integration by parts to evaluate this given integral. That is, we find the integral of e raised to the power of 4t times of cos of 3t dt. So let's do the step 1. In step 1, we let u equals e raised to the power of 4t, and also we let dv equals the remaining terms in this expression, that is cos of 3t dt. So let's apply the integration by parts. So according to the integration by parts, we have to take the differentials on both sides for this u. So when we take the differentials, we will get du equals, we have to apply the chain rule to differentiate this e raised to the power of 4t. So when we do that, we will get 4 times of e raised to the power of 4t and then dt. And this side we have to integrate so that we will get v. So we integrate both sides like this. So integration of dv is v, and integration of cos 3t dt is sine 3t over 3. Now, according to the integration by parts formula, since we let this as u and we have also let the remaining terms as dv, we write the given integral as that is e raised to the power of 4t cos of 3t dt, and this is basically this e raised to the power of 4t represents u, and cos 3t dt, this is represented by v. So according to this integration by parts formula, that is the integration by parts formula is u dv, this equals uv minus integral of v du. So we are going to use this formula, and this means this given integral can be written as uv, that is we will substitute the u. We have this u here, which is e raised to the power of 4t. So it is e raised to the power of 4t, and then times v, which is over here. That is, we multiply this by sine of 3t over 3, and then we have minus in the formula. So I put this negative, then integral of v du. So I substitute the v, which is sine of 3t over 3 times of du, which is 4 e power 3 4t dt. So let's get this simplified. Let me make this a little bit short to have some more space. This is basically the formula. So let's simplify this. So this equals, we can rewrite this as e raised to the power of 4t sine of 3t over 3. And after step 1, this is actually given as positive in the question. So I'm going to put this as positive and transfer this negative into the integral. So therefore this becomes integral of, we'll combine the numbers, that is we have 4 in the numerator and 3 in the denominator. So I put it as a negative 4 third, and then times of e raised to the power of 4t sine of 3t. And then we have this dt. So basically after step 1, this expression goes into the first box, and this is the result. That is, this is basically negative of 4 third e raised to the power of 4t e sine 3t dt. So this goes into the second box. That is the result of the integration by parts after step 1. Now let's do step 2. That is, we have to apply the integration by parts method to evaluate this second integral. So let's do step 2. In step 2, I'm going to let u equals e raised to the power of 4t, and then dv equals, here we have sine of 3t, and then we have this dt. So I'm going to let dv equals sine of 3t dt. So on this side we have to differentiate both sides. So therefore we will get du equals, we apply the chain rule once again. So this becomes 4e raised to the power of 4t dt, and this side we have to integrate so that we will get v. So integration of dv is v, and integration of sine 3t dt, this is basically negative cos 3t over 3. So we have calculated the du as well as the v, which means we will apply the integration by parts formula to evaluate this particular integral. So let's rewrite this original integral. So here I have written the original integral. That is, this right side expression is basically the result of the original integral after step 1. So we are into the step 2, and we are going to apply the integration by parts formula to integrate this expression. So let's do that. So I'm going to write this expression first, that is e raised to the power of 4t sine of 3t over 3 minus this 4/3 is a common term. So I put this as 4/3 and I put a square bracket. And now I'm going to apply this integration by parts formula second time. So it's basically the formula. We will replace this formula, that is u times of v, which is e raised to the power of 4t times of v is negative cos of 3t over 3. This is a factor. And then according to this formula, we have just written this uv. We then have negative of integral of v du. So let's replace this view. That is a negative of cos 3t over 3 is v. And then du is 4 times of e raised to the power of 4t dt. So now I close this bracket. Now let's get this simplified. So this first term remains as it is, that is e raised to the power of 4t sine 3t over 3. I'm going to distribute this negative 4/3 into this brackets. So therefore this becomes, let's work on the negative. We have negative here and we also have negative here. So product of two negative is positive, and we also have 3 in the denominator and 3 in the denominator. So this basically becomes 9 in the denominator. And so we can put this as positive 4/9 e raised to the power of 4t cos of 3t. And then let's work on the numbers as well as the negatives. So we have a negative here, and we have another negative, and we have another negative. So product of 3 negative is negative. So I'm going to put negative. Let's multiply the numbers. We have 4 in the numerator as well as 4 in the numerator, which means it is 16, and 3 in the denominator as well as one more 3 in the denominator, which means the denominator is 3 times 3 is 9. So I put this as 16 over 9, and then we have this integral. That is, after we multiply the numbers, we will be left with e raised to the power of 4t and then cos of 3t. Then have this dt. So basically we got the result after step 2. So according to this question, this is the result of the step 2. So this goes into the box, this expression. And we have also determined the value of k, which is found to be 16 over 9. So this is the value of k. So we write down the value of k equals 16 over 9. Now let's wrap it up. So we can clearly see that the original integral is e raised to the power of 4t cos 3t. And we also have the same similar integral on the right side with the factor negative 16 over 9. And this means we are going to add the positive 16 over 9 integral of e power 4t cos 3t. So that we will get the left side expression as, we already have e raised to the power of 4t cos 3t dt, and then we add the positive of 16 over 9 and then this integral. So therefore this becomes 16 over 9 integral of e raised to the power of 4t cos of 3t and dt, and this equals, we'll be left with this expression inside this colored box, that colored box. So let me rewrite this. So which is e raised to the power of 4t sine 3t over 3 plus 4 by 9. Sorry, this is plus e raised to the power of 4t cos of 3t. E raised to the power of 4t and then cos 3t. Now we see that these two are like terms, that is e power 4t cos 3t dt, and here also we have e power 4t cos 3t, that is both are integrals. And so we can combine this, or we factor this integral, we'll be left with this is quantity 1 times of this integral, and this is 16 by 9 times of this integral. So when we factor this integral, we just have to add the fraction, that is 1 plus 16 by 9, and this equals 1 can be written as 9 by 9 plus 16 by 9. So 9 plus 16 is 25 by 9. So we'll be getting the factor 25 over 9 of the integral of the left side expression, that is e power 4t cos of 3t dt. So this equals the expression on the right side, that is e power 4t sine 3t over 3 plus 4 nines e power 4t cos 3t. So since we want to find the result of only this integral, we divide both sides by 25 by 9, that is we divide by this factor. Or else what we can do is we multiply by the reciprocal of this fraction, that is we multiply it by 9 by 25. That is what I'm going to do. So when I do that, I will get the left side expression as just e raised to the power of 4t cos of 3t dt, and on the right side I have to multiply this 9 by 25 to both terms. So we will multiply 9 by 25 times of e power 4t sine 3t over 3, and then plus 9 by 25 times of, this is 4 by 9 e raised to the power of 4t and cos 3t, and we can simplify this. So 9 goes into 3 as 3 times, and also we can cancel this 9 with 9. So we are left with this is 3 over 25. In fact, if we observe, we can factor this, we can take this, that is we have this common denominator of 25. So I'm going to put this common denominator down below that, and in the first expression we are left with 3 times of e power 4t sine of 3t plus, in the second expression we left with 4 times of e raised to the power of 4t cos 3t. Now, in fact, we can also factor this e power 4t, which we have in both terms. So let's do that. And when we do that, we get e raised to the power of 4t. This becomes 3 times of sine of 3t plus 4 times of cos of 3t. And this all over 25. And so this is the result of the given integral. I'm sorry, I just forgot to put the integration constant c. So let me put this integration constant. So I put this, maybe I've just erased this, and this is basically plus the integration constant c. So this is the result of the given integral.